Thank you so much, Jerry. We very much like the way you did, trying to go with a synergy between the science and the utilization of water and resources. There was a lot of creative ideas in your speech, and I hope it will help to get samples of water any place in the solar system. We can have it. Of course, we could use the geyser on Enceladus, but it's far away, and I hope that we're successful on the moon, where we really lack of clues to get water easily. That's one of the questions. So
we can take a few questions.
Yeah.
Comments, questions. Yeah.
Okay, so okay, very impressive session. But I have a talk on for Jerry for the last one, because you have presented this beautiful set of activities all over NASA, the NASA centers, and so on. So, what can we do in Europe to be a good partner? So, should we also start a set of facilities? For instance, we have a Jovian Antenna Center, DLR. We will have the Luna. We have also some field sites in Europe that are available, but on the area of this core that you have identified. So is NASA doing it all, or are there things that we should do also in Europe with some of the actors that are here?
Well, I mean, there's lots of things that Europe can do. As I pointed out yesterday, when we talk about in-situ resource utilization in general, there's lots of different disciplines. It's not just the mining equipment, there's the storage, there's the robotics, there's the power, all of those things that have to occur, even the law and such. Again, because of time constraints, when I was in Luxembourg a few weeks ago, I gave presentations on ISRU where we broke down ISRU from what I'll call prospecting all the way to storing in the product and having the different functions in between. And we started to discuss, if you have the right interfaces between each one of those steps, anybody can fill that box and you can mix and match. So you could have a very collaborative yet competitive approach to doing these things. So a lot deals with establishing the framework and finding out what is important to each of the space agencies, what's important to each of the countries. So, you know, these are discussions that I've had with several of the different space agencies. I have them with companies and universities. We try to publish as much information, and again, if you go to my Luxembourg presentation, where we specify what are the gaps, what are the technologies that we need to work on.
But on the other hand, in Europe, we don't want only to do...
And anybody can pick those and work on them.
But we want also not only to do the subsystem boxes, we want also to have an overall, you know, system where you can test the whole chain value.
Yeah, and I would say that there is an emerging space economy, as we all know, where there is room for everybody. It's like a big puzzle. Big, large companies, but also small ones with specific key technologies that contribute to the picture. Okay, other comments? Yes, yes.
Okay, thank you. Our question is about JUICE, and first of all, congratulations to everyone on the project, and wonderful launch. We are just a bit worried about what's happening, of course, and we are wondering if you could give us some more details. You say that today you are trying to do something more to unlatch.
You mean for the antenna, for the radar?
Okay. Yes, so it's a mechanical problem, and it's always difficult to know exactly what's going on. The good thing is that we have some cameras on board that we can take images of the antennas, and that's very useful to understand the problem. So we think we understand the problem is that it's a little pin which block the deployment of all the segments of the antennas. So, and one of the reasons is probably mechanical or friction or due to thermal aspect. So what we are doing, because it's very cold there, we unpoint the spacecraft less than 1 hour per day to do some thermal cycling. And we have some constraint here because JUICE is designed to work in the cold environment of Jupiter and not in the warm, so to say, environment in the inner solar system. So we can off-point the spacecraft for 1 hour. So this is what we do in of the last 2 weeks. And plus, we try to shake the spacecraft with the main engine, with the thrusters, to try to unblock the radar antenna. And today, we can activate one actuator to try to develop to deploy the antenna. So we think that the effect of the thermal cycling plus a big kick today, hopefully will deploy the antenna. So this is what I can say today.
We had another comment there, two. Yeah.
Hello, thank you for this presentation. It's splendid. A question regarding ethics and in situ resource utilization. How do you manage, what is the plan for the management of the tension of the interest between the consideration regarding forward contamination, for example, of water resources, when you create, for example, that pocket of liquid water in a glacier, and the fact that you might contaminate it with terrestrial life form at the same time. So there is a tension between the research for life and the in situ resource utilization. Is there like, what is the political or the administrative setting that you consider for managing that? All those questions, because this will be very practical questions.
So here again, there will always be some level of science before we do the processing. And I think you're referring to Mars contamination, because lunar contamination is not an issue with looking for life. So on Mars, the different water sources, if I get the water from the ubiquitous soil, if I get the water from hydrated minerals, there are no issues with looking for life. It's when we go after the subsurface ice. So now it becomes a question of, before I ever try to mine that water or extract that water for use, what type of measurements would I take of that ice sheet to prove or disprove whether water is there? And to give you an example, back in the 90s, I was at a conference at JPL on Mars, water, 98 timeframe. And somebody said, oh, we're looking for subsurface aquifers for life, and oh, by the way, we'll use it for ISRU. And I raised my hand and I said, so you drill into this aquifer, you find life, can I now run it through an electrolyzer and kill it? And I did that as a joke, and everybody laughed for about 2 seconds and then said, no, you can't do that. And I said, well, then it's not a resource. It is, you know, it's of science interest. So that is, if we find life in an ice sheet, then it's not a resource. If we don't find life in an ice sheet, then it might be something that we would consider. So hopefully that answers that question. There's a lot more thought that needs to go into it, but here again, if we're going to any water source on Mars, we will have to sterilize the hardware in the process of looking for that life.
Many thanks.
Okay. One more question behind you.
Last one.
A question for Olivier or Athena. As was mentioned, JUICE and Clipper were conceived together 15 years ago or so. And you mentioned there is a synergy between the two, but you weren't very specific about what kinds of questions could only be answered by the two spacecraft operating in concert. Could you offer up some ideas on that?
I start, and I'm sure Athena will complement. Well, to have two spacecraft at the same time in the Jupiter system, I think it's a unique opportunity. First, for plasma science, because you know when you are in a plasma environment, everything is variable in time, in space. That's why on Earth we have multiple spacecraft missions. So at Jupiter, to have already two spacecraft to study the plasma environment would be quite interesting. And the plasma is very interesting at Jupiter because not only for the plasma itself, the magnetosphere, but the link between the moons and Jupiter, that's also very, very, very interesting to study. So to have 2 points will be very interesting. For moon science, you want to complement? Or?
Yeah, as I mentioned in my presentation, you're looking at 2 different categories of moons. One is like Enceladus and Europa, and the other is like Ganymede and Titan. So you have these 2 different moons that actually the complementarity between the instruments, Europa Clipper has at least a couple of instruments that are different than on JUICE. So it's as if you are having a larger payload that can give you synergistic science on these moons through the radar measurements, stereoscopic measurements also, you know, whether stereoscopic with spectroscopy or with imaging. All of this together, I wanted to mention that Olivier has put together a very nice group where Europa Clipper people discuss with JUICE. And so we have how many years before we get there to get our act together and do all these synergistic measurements. But remember that Galileo and Cassini also did synergistic measurements at the time when they were both around Jupiter at that time, and we got some very exciting results on the magnetosphere.
Maybe one very quick example. When one spacecraft will do a flyby of a moon, like Europa, Ganymede, or Callisto, so there will be in situ measurement around this moon, so magnetic field, particles, etc., while the other spacecraft will be somewhere else in the system looking at the aurorae of Jupiter. And it's not possible to do with one spacecraft because when you do the moon flyby, you don't observe Jupiter, you observe the moon. So we have a lot of these kind of ideas to work together and to do 1 + 1, it will be more than 2, it will be very interesting.
I just wanted to compliment because we got a question before. I'm also chairing the COSPAR panel on planetary protection, and I just wanted to say that we are allowed to crash on Ganymede because Ganymede is category 2, and we have demonstrated that the probability of contaminating the ocean on Ganymede is very, very low, whereas we cannot crash on Europa because Europa is category 4, and it's a body that is not allowed. You're not allowed to crash there because, as I said before, the ocean is very close to the surface, and you may have a chance of contaminating. But Jerry said it very well that we need to sterilize anything we send out there so that we don't take a risk.
Maybe the best end of the 2 projects will be disposal of Clipper on Ganymede, so high-speed impact, while JUICE will be at this lower orbit at Ganymede, 100 kilometers, 200 kilometers, so we can witness what happens. That will be the best end of the 2 projects, I think.
And with this crashing conclusion, I thank everybody for this session. Athena, I cannot avoid just advising you to reconsider how beautiful is our planet. Because you say, and I even don't like our planet. It's just super beautiful. We can have coffee together, so I will convince you. We knew that this would have been the most beautiful session. We hope that you enjoy it as much as we did. Thanks for staying with us. And we need to reconvene 11:20, 20 minutes for the coffee.